All right, everyone. So today we're going to be talking about ratios, the topic here. And let's talk about the key vocabulary here. So a ratio is a comparison of two quantities by division. You can write the ratio of two numbers, A and B, where B is not equal to 0 in three ways. A over B, A colon B, and A to B. And these are usually still said as A to B, even when you have the colon there. You usually express A and B in the same unit and write the ratio in simplest form. So very important, make sure they are in the same unit. And we have simplified as much as possible. Note that B cannot be 0, as mentioned in the key vocabulary. So number 1 says simplify the ratios. So when I go to look at letter A, I notice that the units don't match. So automatically, I know that's the first step I need to take is getting the units to match. So we're going to need to change from yards to feet. So we know that 1 yard is equal to 3 feet. Therefore, 3 yards is going to be equal to 3 times that, which is 9 feet. All over the original 6 feet. Now that we have the same unit, we can look for a greatest common factor. And the largest number that divides into both of these equally would be 3. So we're going to divide the top and the bottom of the ratio by 3. And then we can write the ratio out in its other forms using the colon here. And we can also use the word 2. Now for the next one, the procedure is the same. We need to get both into the units of centimeters, so we're going to have to convert that meters into centimeters. And we know that 1 meter is equal to 100 centimeters. So since 1 meter is equal to 100 centimeters, 4 meters is going to be equal to 4 times that, which is 400 centimeters. So we're going to keep our numerator or our top the same, and we're going to change it to 400 centimeters on the bottom to change the units so that the units match. Now I'm looking for the greatest common factor of 12 and 400, which is 4. So I'm going to divide the top and the bottom by 4, which is going to give me 3 centimeters over 100 centimeters. And then I can write that out in the other ways that we can write ratios with the colon and with the 2. Now for number 2, a pygmy rattlesnake has an average length of 18 inches, while a western diamondback rattlesnake averages a length of 5 feet and 6 inches. What is the ratio of the length of a pygmy rattlesnake to the length of a western diamondback rattlesnake? Well, the first thing I notice in the problem is that the first type of snake is in inches, and the second one is in a mixture of feet and inches. So we need to get that second measure completely in inches so that it matches that of the first. We know that 1 foot is equal to 12 inches. 1 foot, 12 inches. So therefore, if we have 5 feet, we have 5 times that many inches, which is going to lead to 60 inches. And then of course we have to add the 6 inches back that we had as well, because we have not only 5 feet, but 5 feet and 6 inches. So then we just do 60, which is 5 times 12, plus 6, which is 66 inches. So those are equivalent amounts right there. 5 feet and 6 inches and 66 inches are the same. So now that everything's in the same unit, we're going to look at the phrasing of the question. It says, what is the ratio of the length of a pygmy rattlesnake to the length of a western diamondback? So if you look back at the key vocabulary, A to B. So our A is going to be our pygmy, and our B is going to be our western diamondback. Now we're ready to set up the ratio. 18 inches over 66 inches. And then we're going to reduce that fraction by looking for its greatest common factor, which is 6. which gives me 3 inches over 11 inches. And then we can write it out in other forms, like 3 inches colon 11 inches, or we can write 3 colon 11 and then write inches at the end. The measures of two complementary angles are in the ratio 1:3. What are the measures of those angles? So let's go back to our geometry knowledge and think of what complementary angles are. Complementary angles are angles that add up to 90 degrees. Now if we think of the ratio 1:3, that means for every one piece of the first part of the angle, there are 3 pieces, corresponding pieces to the second angle. So in total, that's going to be 4 separate pieces, and each of these pieces can be represented by the letter X. So the first part of the ratio contributes 1x, and the second part contributes 3 x's. And the total of these, their sum, which is addition, is going to add up to 90 degrees, which makes them complementary angles. So 1x from the first angle piece, and 3 x's from the second, and that adds up to 90 degrees. Now I just chose x as a random variable. You could use any variable here as long as it's consistent throughout the problem. I'm going to combine like terms and get 4x is equal to 90, and divide both sides by 4, which gives me 22.5 degrees. Now that's my first measure. My second measure is 3 times that, which is 67.5 degrees. And that total should add up to 90 because they are complementary, which it does, and that's a good way to check your work here. The lengths of sides of a triangle for number 4, the lengths of sides of a triangle are in the extended ratio 2:4:5. The length of the perimeter of the triangle is 77 inches. What is the length of the longest side? Well, the first side gives us 2 x's, or 2 pieces. The second side gives us 4 pieces, and the last side gives us 5 pieces. And the total of the measure of the sides is equal to its perimeter when we add that up, which is 77. So we can add these up and set them equal to 77. And we can use algebra to simplify. By combining like terms, we get 11x. Divide by 11 and we get 7. And then we have to plug that x back in. So we know the longest side is the one that's 5 pieces of that ratio. So that's 5 times 7, which is 35. And don't forget about your units, which is in inches according to the problem. So the on your own, go ahead and pause the video and come back when you're ready after you've tried the on your own problem. The perimeter of a rectangle is 60 centimeters, and the ratio of the sides is 3:2. Find the length and width of a rectangle, and the hint says draw the rectangle. So we're going to go ahead and draw the rectangle, and we're going to think of the properties we know to be true about rectangles from our previous knowledge of geometry. We know that a rectangle is a type of parallelogram, which means that opposite sides are congruent. So really, they only gave us 2 of the side measures, but that's all we actually need, or 2 expressions that represent the sides, because we know that the opposite sides are congruent. So the 2 smaller sides are going to represent the 2 parts, the 2 x's, and the longer parts are going to represent the 3 x's. So we know that we had to have 4 sides included because we know a rectangle has 4 sides. It's a quadrilateral or parallelogram, which have 4 sides. And we know that the sum of these 4 sides is going to be equal to the perimeter. So be careful whenever you're doing perimeter, you need to make sure you're adding up as many sides as there are for that particular shape. So now we can just combine like terms, which is 10x is equal to 60, and divide by 10, which gives me x equals 6. Now to find the actual dimensions, we need to plug the x back into the sides of the rectangle, which give me 12 and 18 centimeters each. So here we're going to solve a proportion. So the way that we solve proportions is we want to make sure that it is a proportion by looking for that equal sign between the 2 fractions. Now if there's any other type of operand here, like a multiplication, division, or subtraction, or addition, you cannot proceed with this procedure, which is cross multiplication. you can only cross multiply when there's an equal sign there. So we're going to go ahead and cross multiply because we figured there is the equal sign there. Just make sure, always double, triple check that there's the equal sign. And now we're going to proceed with the cross multiplication. Doesn't matter which one you do first. It's all going to be the same in the end. 3x is equal to 40. Now we're going to divide both sides by 3, which gives me 40 over 3 because 3 does not go into 40 evenly. And that gives me x equals approximately 13.3 repeating. So you can leave your answer as the improper fraction as it's more exact, but the decimal approximation can be useful in this step to check your work. So what you can do is you can actually plug that x value back into the equation here. And what you can do is in your calculator, you can go ahead and do 3 divided by 8, and then you can separately do 5 divided by 13.3. Now since we rounded to get the 13.3, your answer is not going to be exact, but these two fractions should come out to be the same thing when we divide them in the calculator. So 3 divided by 18 is 0.37 or 375, and when you do the other division, it's also going to come out to be very, very close to 3.75. And if you left it as the improper fraction, it would have been exact. So this is just a little way you can use to kind of check your work and ensure that you did it correctly. It's always good to check your work. That's how you can avoid mistakes on tests and quizzes and whatnot. So the same procedure goes on for B. We're going to cross multiply. Now here you have to be a little bit careful because in this question we have an expression that is a binomial, so we're going to have to distribute that, use the distributive property. That's going to give me 6y plus 18 is equal to 60. I subtract 18 on both sides, I get 6y is equal to 46, and I get y equals 7. Now to check my work, I can go ahead and plug that 7 back in for y. That's going to give me 10 over 12 is equal to 5 over 6. And you can see that if we divided 10 and 12 each by 2, that would reduce to 5, 6. But you can also plug each of these fractions in the calculator and confirm that they come out to give you the same decimal approximation. Each of these give you about 0.83. And that confirms that we did the math correctly. So yeah, that's how you do it. Go ahead and give it a try on the assignment.